Si te molesta, dímelo, ¿eh? Bueno, yo es más que nada por el tiempo.
No me molesta nada. Te voy a poner la presentación. Bueno, buenos días a todos. I will do the presentation today in English. This is the third session that we hold for the master program. In this case, well, let me present myself at the beginning, because many of you don't know me. I'm Fernando Garcia. I'm the global coordinator of the project of digital twins for infrastructures and cities. This session today, as I said, it's the third conference that we are holding in the course of a Master in Digital Twins for infrastructures and cities, but it is also addressed to professionals of the digital transformation of civil engineering, and particularly to professionals in ports engineering. Today we will be holding a conference about the digital twin that SENER developed for the Port of Callao, and it's a pleasure and an honor to host today at the Universidad de Escuela de Caminos, Canales y Puertos of Madrid, to Xavier Pascual, the Director of Consultancy Services and Innovation of SENER, and to present this innovative project that will illuminate what we are trying to teach at the master program. But before we give the floor to Xavier, I'm very happy to introduce to someone who is working with us and participating in the master as a student, but who is also a prominent engineer of SENER, and he's particularly keen on railway engineering, but at the same time this digital view will also enlighten the presentation of Xavier. Let me introduce you to Ivan Revilla, as I said, a student of the master and professor of SENER. Thank you.
Thank you, Fernando. I'll be very brief. I'll just give you a tip about Xavier first, and then about the project. So, Xavier, just to introduce himself before, Xavier holds a master's degree in civil engineering from the Universidad Politécnica de Catalunya, a master's degree in management ports, and as well is an MBA by SENER, reflecting this a robust academic background. With a spanning career of 24 years, he has cultivated profound expertise in business strategy, team management, and sustainable infrastructure design. Since January 2023, Xavier has assumed the role of Global Director of Consultancy Services and New Technologies at SENER, overseeing the global strategy of the company and business development. On top of that, he's as well a professor, so he works in the Universidad Politécnica de Catalunya as an associate professor. So as you might see, he encompasses everything that an engineer can bring today. So just the technical role, the managerial role, and on top of that, all the academical contribution. Just to finish, I'd like to give you a very brief introduction for the project. There is the Port Callao in Lima, so situated 15 kilometers from Lima. The Port of Callao stands as Peru's largest and the South American Pacific coast's most expensive port. So the Multipurpose North Terminal, just to give a number, it can manage over 1 million TEUs and handles over 12 billion metric tons of general cargo. So related to the digital experience, I'll give you just the three main reasons that were the conference that we'll cover afterwards, that are on-site data collection with an LOD, the 500, integration of operation and maintenance tools, and management indicators. So you'll see everything right now from Xavier's point of view, and please, a warm welcome to Xavier.
Thank you, Ivan. Thank you, all of you. Okay, here we have the presentation. I will move a little bit, so I will appear. I hope I will appear on YouTube also. Today, I would like to introduce you our project of the digital twin. Okay, it has been evaluated since 2018. We started working on that in 2018, and you will see our evolution. Okay, so I have prepared a brief presentation. After that, we have 10-15 minutes for any doubt, any consultancy that you have. So please take notes or whatever for the questions later. Okay, so well, I proceed with that. First of all, this is the agenda of my conference today. I will brief summary about SENER, because maybe some of you don't know SENER. Then we will talk about digital twin. I have put a question mark here because all of you talk about digital twin, but I think that we should agree on what is a digital twin. After that, the main purpose of the presentation for sure is the use case of the digital twin in Callao Port, and finally we will have the Q&A. So just a brief introduction on SENER. Well, SENER is a multidisciplinary engineering firm, okay, that was founded by two brothers in 1956 in the north of Spain, in the Basque Country, in Getxo. Okay, right now we are more or less 3,305 people working in SENER in more than 20 countries in the 5 continents. We have more or less right now projects in 90 different countries, which gives us a global overview of what is a project and what are the requirements of our clients. No? Always we have fundamented our strategy in these 3 key values, in innovation, quality, and independence. Sorry. Today I will focus on innovation in SENER. Another key point for me is that we have right now 80 patented families, okay, developed by SENER, focus of this innovation. This is the structure of SENER. We have SENER with different companies, SENER Aerospatial, SENER Mobility, SENER Energy, SENER Advanced Facility, and then we have SENER Renewables Investment and Sagarbarbi. The activity on ports is inside mobility, okay? My activity as consultancy service and technology is transversal in all mobility, so we affect all these sectors in SENER. What we do in mobility? Mobility, for sure, we do ports. We have more than 140 ports designed by SENER. We have a large experience on rails and transit, also highways, airports, building, water environment, and consultancy in new technologies. This is an area that started in SENER 3 years ago, okay, when we saw that in the different markets we have a lot of projects related to digital solutions and innovative solutions, so we decided to create this specific business unit inside mobility that gives services to all the different markets. What are the services that we offer to our clients in SENER? We cover the full life cycle of any project, from the very beginning, when we are in the planning stage, until the O&M. Okay? Today, we will focus on the O&M, because, as you will see later, the digital twin should have a purpose. Okay? It's not just building a model. We should use digital twin for something. Okay? Then we will discuss what are the uses of a digital twin, but mainly are for O&M. Okay? For sure, the life cycle of a digital twin can start in the planning stage, then move to the design stage, the construction stage, and finally operation and maintenance. But maybe this is for a greenfield. But if we are talking on a brownfield, maybe we will go directly for a digital twin here. So SENER is different from other engineering firms or consultancy firms, because we cover the full life cycle, and we want to be supporting our clients from the very beginning till the O&M of the infrastructure. And this is why we were one of the first companies in the world to develop a digital twin that is today what I will show you. In SENER, we are in digital engineering from the very beginning. Okay? We start in 1967 with a software developed by SENER, which is called Foran, CAD/CAM software, 3D software, in 1967. Okay? So we have a large track record, more than 50 years, working in 3D in SENER. First was the design of vessels. Then we moved to the aerospace and the energy. And in mobility, in the infrastructures area, our first BIM project was in 2006. Okay? In 2006, we had 3 different 3D modeling BIM. Okay? One on a building, the high-speed station in Barcelona, then another high-speed in Logroño, and finally it was also the first port project in BIM. It was Hutchinson Container Terminal in Barcelona, now called Best Terminal in Barcelona. We were participating in that project, and we decided to implement BIM in that project. Okay? So the origin of SENER working in BIM, which is a part of a digital twin in ports, was in 2006. So we have a large track record working in BIM and digital solutions in ports. Okay? So then we move 2012, we start doing BIM consultancy for others. Due to our experience inside, we are doing also consultancy services for our side. Then the BIM management and the digital project delivery. We create the BIM office in SENER in 2017. We started, this is the origin of a digital twin, the BIM data management in 2018. Okay? 2021, we start integrating systems inside the digital twin, you will see later. Okay? And finally, we have the ISO. Okay? So this is the life of SENER working in digital solutions and digital engineering. So let's move to digital twin. Okay? When we talk about digital twin, we should be able to answer all these questions, okay, before starting. First thing, what, who, where, how, when, and why. This is something that all the journalists are used to answer, no? So if you are not able to answer all these questions, please do not start developing any digital twin, okay? Let's focus on what is the particular question that you should be able to answer in a digital twin. First one, what is a digital twin? Later, maybe we can discuss, because now Ivan can have a different idea of mine regarding what is a digital twin, or Nacho, or Javier, or Sandra, okay? So this is something that has to be clear, and if you are working as a client that needs a digital twin, you should have your own idea of what is a digital twin. If you are working as a consultant, you should try to answer this question, okay? So this is, for me, very, very important. And in many, many digital twin projects in which we are involved, this is the first thing that we have to agree with our clients. What we understand for a digital twin. This is the first one. Then move to the second one. Who will develop or use this digital twin? Normally, it will be developed by an engineering firm or a group of engineering firms, which is different, but then it will be used for the engineering department of the client, for the construction department of the client, for the operation department of the client, for the maintenance department of the client, for all of them. The digital twin will be different depending on who is using the digital twin. So this is something that also you have to have a clear idea before starting building any digital twin. Then, another question, where is needed a digital twin? We need at the office, we need on site when we are constructing a building or an infrastructure. This is different, you will see, or in both cases. How? How we create a digital twin? It means the tools. You will see later, okay? You can start with one brand, then move to another brand. You will need or not need a digital twin platform. Which size of the platform? It depends on the data. It depends on the O&M that you will performance. So all of that, it's key before starting, how we will build the digital twin. Another thing, when? When do we need a digital twin? We need a digital twin during the O&M stage? It's different, okay? So this is something that you have to have a clear idea before starting that. And finally, why do we need a digital twin? What is the purpose of the digital twin? Now, it's very trending. Digital twin. You have here a master's degree on digital twin, okay? A lot of people talk about digital twin, but why do you need a digital twin? which is the purpose of the digital twin. This is something that if it's not clear from the very beginning, then maybe you will not have success with this digital twin. So please, before starting any digital twin project, please question all these questions to you and try to have the solutions. If not, take your time, okay? In order not to waste time and money, okay? So these questions we will be able to answer during the use case of Callao, okay? Let's try to see what in SENER we understand for a digital twin, okay? For me, a digital twin should be used during the O&M stage, okay? So here you have the maintenance stage and the operation stage, okay? There are two main parts, okay? Talking about maintenance, okay? There is a tool that, if somebody is familiar with the rail or the aerospace market, for sure knows, is RAMS. RAMS analysis is a standard methodology, okay? RAMS, it means reliability, availability, maintainability, and safety, okay? This is a methodology that comes from the aerospace that now is a standard and mandatory in all rail projects. And we were the first company to apply that in ports. It was in the Panama Canal, okay, where we did the RAMS analysis to see the reliability of the first set of logs. This methodology allows you to detect which are the risky parts in your asset in terms of reliability, availability, maintainability, or safety, okay? So, if I know in my asset, in my infrastructure, which are the key points in terms of reliability, I will focus my efforts of IoT in that key points. So I will manage big data of these IoT devices that I have put. The main purpose of that is to go to a predictive maintenance program. So we have to avoid corrective maintenance, go to a predictive maintenance, and this is needed, okay, to increase the performance of the asset. That will be a key point of the digital twin. One of the whys of the digital twin is to increase the performance of the infrastructure, okay? This is the maintenance part. Then if we move to operation, for operation, you have enterprise asset management system that is close related to maintenance, but also you have SCADA, you have dashboards, you can have the BIM model, okay? All of that will allow you to have KPIs, key performance indicators, okay? In order to see, our general manager always says, if something is not possible to be measured, it's not possible to follow a performance. So we have to have monitoring of this evolution, okay? So we have operation, we have maintenance, all included in a digital twin that will be included in a control center. In another way is this. So digital twin is not just a 3D model, okay? Lots of companies, I will say majority of the company, talks about digital twin and they think that it's a 3D model. A fancy 3D model, but a 3D model. For me, is something that could be needed for a digital twin. It's not mandatory. I think it's good to have, but it's not a digital twin, a 3D model. Okay? A 3D model is a 3D model. A digital twin, it's all of that and more things. We need site data on real time. We need enterprise asset management systems, SCADA, a lot of softwares and tools related to O&M. We will have microgrids, we have IoT devices, and finally we have dashboards, okay? All of that inside a collaborative platform, because all of this will be developed by different teams, okay? But there is one key point that you have to keep in mind, that is the single source of truth. So we need that the data is where the data should be. If it is in the SCADA, it's in the SCADA. But if I need the data of the SCADA to do something in the dashboard, I will go to the SCADA, collect the data, process the data, and move to the dashboard. but I will not copy the data from the SCADA to the dashboard. The data will be on the SCADA, or in the enterprise management, or in the IoT devices, okay? So everything is connected in a digital twin. Everything should be connected in a digital twin, okay? Well, after that introduction, let's move to the real case in Callao. Well, I think that Ivan has done a very good introduction. Just to summarize, we are in Callao, in Peru, okay? And you say, Callao, Peru, 2018. The first digital twin in ports in the world was that, okay? It was awarded by the Association of the States in America in 2022, okay, as the Excellent Industry Portuaire, okay? So it could seem that the first digital twin should be in the United States or in Australia or, I don't know, Germany or Spain or whatever. It was in Peru. And the story, I think, it's quite important. Why in Peru? Because in Peru, they had a need, and also they had two key people, the engineering manager and his second, that were very interested on that, because they saw the opportunity that the digital twin could give to them. They had a huge problem. I don't know if somebody of you has been there, but this is a very old terminal, okay? They had to do some enlargement, you will see later. But they had, the main purpose at the very beginning was to have digitized the utilities, okay? When they had a problem with water, electricity, they didn't know where the utilities were, okay? They had no drawings, not in paper, not in AutoCAD, okay? So the only way to find if there is a problem with water was going there, picking, and going this. So they asked us, is there any way to have all of this digitized? We said, for sure, we can do that. And we start building the digital twin, thinking on the maintenance, okay? The start of the digital twin in Callao was to improve the way they do the maintenance. Okay, then we will see how we move from maintenance to operation. So we had that in 2018. In that meetings, I asked the engineering department to join to the team, the maintenance team. Okay, because the maintenance asked the engineering, where are the utilities? The engineer said, I don't know. Okay, let's try to put in the same table engineering and maintenance. And also operation, I was asking. Okay, it was very difficult at the very beginning. Very, very, very difficult. So maintenance said, this is not with me, it's a problem of engineering. If you want to solve with that, perfect. Operation, nothing. You will see later that maintenance and operation now are the ones that are asking us to improve this digital twin, okay? So I have always an example, okay, related to that before continuing. Why I ask always, or we ask always to the clients to put on the same table operation and maintenance when we are starting building a digital twin? I always put the same example. Some of you have listened to me before. If I have a chair with wheels, okay, and one wheel breaks, what the maintenance team will do? Change the chairs or the wheel? It's not an easy question, but it has a lot of affections, okay? In terms of maintenance, if you change the chair, it means that in your stock, in your warehouse, you need chairs. If you change the wheel, you need wheels. When I build a digital twin, if I change the wheels, I need to split the chair between the different components. So it affects the BIM model. But also it affects the enterprise asset management, because I need a close relation between the BIM model and the enterprise asset management, okay? So, but if the strategy is to change the chair, I don't need to draw or to model in the 3D the different components of the chair. It will be just one chair. And then in the enterprise asset management system, there will be a direct connection between the chair and one single point that is the chair. And in the warehouse, there will be chairs, okay? This is something that it's not easy to define at the very beginning. in a greenfield project, okay? But it's something that you should ask the teams to be involved from the very beginning, all the teams, operation and maintenance, okay? So let's move. Port of Callao, brownfield project, existing terminal. They don't have any drawings, anything in digital. First thing to do, to build a 3D model. With LiDAR, okay, we're moving all the terminal, okay, we have a lot of cloud of points, okay, and with LiDAR, and also 360 photos that we did with our helmets, and also some sketches done by our team on site, we were able to build a 3D model of the terminal, okay? The origin was a LiDAR scanning of all the terminal, okay? So with this, we have a LiDAR scanning, we have 360 photos, we are able to build, okay, the properties, it's running? Yes. The properties of this model, okay? We are talking about a model right now, 3D model, okay? So, and we structure, you see here at the left, the structure of the 3D model. The structure is not something that we can choose with no criteria. The criteria was the way they were doing the maintenance and the operation, okay? It's very important to structure the 3D model according to that, okay? Why? Because of the chair. Remember the chair and the wheel, okay? So we defined the different, here you see the utilities, low voltage, high voltage, all of that is structured, it's say, in different levels, let's say, okay? But we have a 3D model, okay, of everything on site. And the starting point was the LiDAR, okay? So with this, we have a clear mapping of all the infrastructure. Here you see the doors, the automated doors that we have seen in the LiDAR before, how we convert this LiDAR into a 3D model, okay? So we have now a 3D model of all the terminal. Okay, how is the time? Okay, I'm fine. So you see here the level of detail, you will see later, okay? But we structure all the model, okay? Let's move. As Ivan has said, we have developed this in BIM Lot 500. It means that is field verification. Why that? Because we are using this digital twin for operation and maintenance. So we need real data, verified data on site. This is key point, okay? So here, what you will see now, for example, I think that is in this video, is the piles, okay? Yes, the foundation, the piles. Our client had a report of more than 3,000 pages about the status of the pile, okay? We transformed these 3,000 pages on that. You see each of the pile, the status in terms of maintenance of each of the pile. So the maintenance team is able, just clicking on that, to see each pile, what are the maintenance activities that has to be done in each one. And as you will see later, they are able, with iPads or with cell phones, once the activity of maintenance is finished, to update the status of that pile automatically, so the BIM is updated, okay? So the digital twin has always the updated information, okay? So here you see how the iPad, the appearance of the iPad, so this is the visualization that the people of maintenance had about the digital twin, okay? So they can go on site with the cell or with the iPads and see, and here they can have the checklist and all the details of each of the piles, okay? What are the activities that has to be done? And then they have to sign, they have to put a photo, okay? So everything has the history of each piles and the activities of the maintenance. And this is also, you can see, we can have a photo. So everything on an iPad, okay? No papers on the terminal, okay? So, and everything synchronized on real time in both directions. This is key point also, okay? So this is very useful for the maintenance team, okay? And then you can filter with the status of the foundation, which are repaired, by whom has been repaired, okay? Which are the different status. This is in Spanish, sorry, but our client asked us to do that in Spanish, so this is why this is in Spanish, no? So this is very useful for the maintenance teams. They are using that, okay? Because they go on site, they see what they have to do, they do the job, and then they update. And all the team has the same information at the same time, okay? More things. Then we move to operations, okay? We have maintenance, let's do something regarding operation. First thing is to integrate SCADA, okay? It means real-time signal and digital data on real time, on your phone, on your data, on your iPad, sorry. So here you will see, this is the main intake in the terminal, okay? We have done, here you see the level of detail of the, we can have all the information here, very easy, okay? And then we will move to the transformer, and we will see the data of the SCADA related to the transformer on real time. And we can put warnings on that. So if we achieve some, I don't know, 30 degrees of temperature, for example, we can have a warning on the cell of the maintenance lead, and he can decide to send somebody there and decide if it is a problem or not, okay? But we have, okay, you will see here, we can select the transformer, and in the same side, in your phone, in your laptop, you can see here at the right a brief summary of the main characteristics of the transformer, okay? The main characteristics, say who was the vendor, whatever you want, okay? Instead of going to a library and find the specifications of the transformer, you have here a brief summary. But also, you will see here that we are linking drawings, technical specifications, technical requirements, vendors information, all of that can be linked. I think that here now you will see a drawing. I think so. Let's see. It comes, yes. Here we have a drawing, okay? So we have the drawings, okay? Everything through the same portal, website, or whatever, okay? It's not needed to go to different parts. Everything is connected. Everything, all the databases are connected, integrated, okay? So, and finally you have here the SCADA was Ignition, is the brand of that you have, and here we are connected to Ignition, so we have a direct link to the SCADA, and we are collecting the real data coming from the SCADA in terms of temperature or whatever, the different characteristics that we want, okay? It's not needed to go to the SCADA to see the signal. We are connected directly to the SCADA, okay? Just the same website from any part of the world. The only thing that you need is a good internet connection, okay? It's the only thing. Everything is connected, everything is integrated. More things. This terminal has to be enlarged, okay? In SENER, we have done the master plan of this enlargement. And one thing that our client asked us is to simulate future scenarios in this particular case, is future scenarios of the civil works and utilities, okay, that will be. Here you see the overlaps between the existing terminal and the future terminal. So we can see which piles will be affected or not affected during the construction, which piles should be removed for the future stage. So instead of having the current project and the future project and try to overlap drawings or in AutoCAD or whatever, we have this in 3D, okay? So it's very easy, sorry. It's very easy to see which are the piles affected, the utility affected, all of that through the same digital twin, okay? So everything is integrated and we are able to overlap different situations of the future terminal, okay? This is future scenarios, let's say, for construction, okay? We have done also feature scenarios for operation and for maintenance, okay? You will see now. But here you see the level of detail, it's 500, as Ivan said, so we have 450 plus the field verification, we have maximum level of detail, okay? And also, what we see here is the different characteristics of the projects, okay? The future project and the existing one. We can compare the size of the piles, the size of whatever, okay? So we have the two projects in one single window, okay? Which has a lot of advantages during construction, okay? Let's move to operations, okay? We have done simulations and emulation, okay, in the digital twin, which is one of the, for me, main advantages of a digital twin, to be able to simulate and emulate future scenarios of operation or maintenance, okay? Let's go to the, well, first of all, one of the main problems of Callao's port, and most of the ports in the world, but Callao's particular, is the access, okay? There are a lot of queues of days to enter into the port, okay? Queues of days, it means a lot of money, okay? To avoid that, we decided automated gates for this terminal, but also we did that, okay? We did simulations to find the best configuration of these automated gates. You see here that there are 8, okay? But we did these simulations with 6, with 9, with 10, okay? Seeing pros and cons of the different number of gates. And also you see here that I'm able to close one gate, to put something related to maintenance here, okay, to put lights, and to see how, when I put a point here, how it affects, you will see now with the red one, how it has to move. So if it moves, it affects the queues here, okay? So we had here, for the design, it was used for the design first and then for the operation. But for the design, we had historical data, okay, of all the entrance to the port. With this historical data, we built our own algorithms, okay, in terms of see how we should design the gates, okay? And we were able to do that because we had the digital twin built, okay? So with this tool, we are improving the way that we design. I always say, when I teach in class, that ports should not be designed in the same ways in 2024 that I started to do in 2000, okay? We have new technologies, we have different tools, and it's not possible to design any infrastructure in the same way now that 20 years ago or 5 years ago. Okay? So this is a clear example of how technology and digital twin can support for the design, okay? Using simulations of this. But, well, here you see this is kind of fancy with the car and running, okay? This is more a demonstration of the capabilities that we have, but let's move to, here you will see, okay, these simulations, how it affects, okay, no, this is the same one, sorry. Now, I will try to do that quickly, okay. Here you see the difference between having all the gates open, this is moving quick, and half of the gates. You will see, take a look here, how the queues are creating, okay? How having 8 doors or 8 gates open or just 4, the queues that you see, okay? So this is with real data, okay? It allows us to do a good design, and we are able to support some part of the queues, okay? Not all the queues, due to the space that we have. So we decided to put 8 because it was the minimum gates that allows us to have, let's say, acceptance on the queues, okay? But we did that also, sorry, on the berth, okay? To see, depending if the berth is open or it's closed, how it affects, you see the tracks here, okay? So the potential of this digital twin is to see how we improve the design, okay, of new components like the automatic gate, but also, as you will see now, later how we improve the operations, okay? Because this is a brownfield. So when we talk about operations, what we did is to incorporate this is the digital twin, and we have incorporated in the same digital twin, everything connected, everything integrated, as I said before, our simulator, okay? So it's not needed to go to the simulation tool to do this. We can do the simulations through the same window. Everything is integrated, everything is connected, okay? Single source of truth. This is the concept of the digital twin. So all what you have seen, we have integrated, okay? So any change on the model or digital twin affects the simulation. So this is why we have integrated that, okay? Because we want to use this tool for emulation, okay? It means to improve the operations with real data on real time. We were designing, taking into account historical data. Now we have data due to the booking system that the terminal has, okay? We know how many trucks will arrive in the next 3 days, 4 days, 5 days, and when they will arrive. So we can decide which is the best moment to do the maintenance operations in the gates, for example, okay? Because maybe next Wednesday I had 3 vessels arriving and a lot of trucks coming, that they have to dispatch all the freight in just 1 day or 2 days. Okay, maybe the best day to do the operations, the maintenance of the gates, it's next week on Monday, because I don't have any vessel, I will have less trucks in the terminal, so it's much better. So with this tool, the maintenance team knows when the vessels arrives, and they can decide when is the best moment to do the maintenance, okay, in order to affect the less to the operation. And finally, we can have dynamics KPIs, okay? Here we integrated, there was a lot of discussions between the Port Authority and the concessionaire regarding some KPIs that are contractual, okay? Like is the time that passes from the last mooring it has been done in the vessel and the start of the discharge of the silos, for example, okay? Now, as we have real-time information, there is no discussions. Port Authority and the concessionaire has access to the same data, single source of truth, on real time. So there is no discussions when we have finished the mooring analysis, the mooring of the vessels, and when we have started the discharge of the freight. Okay. So we integrate here the MOST, which is the software that controls the operations of the silos, but also the SCADA and also different softwares and tools. Okay. So with this we can have KPIs, useful for contractual issues, for example. Okay. So I think that this is all what I wanted to explain to. I have been on time, so we have now 15 minutes for any discussions, questions, or whatever. Sorry if I have been so fast, but the organization has asked me to be sharp on that, so we have 15 minutes for anything you have. So I don't know if we have something on YouTube or not. Nothing yet? Okay.
I have a question.
Okay.
Well, first of all, thank you very much. It was a wonderful speech. It has it's an economical question.
Yeah.
So you spoke at the beginning of the importance of analyzing beforehand what do you want the digital twin for, and what are the needs that you want to cover, what are the problems that you have. But from an economical standpoint, what is the cost of developing such a digital twin for a project of this complexity, and what is the economical gain in the course of the
return on
use?
investment? No?
That's it.
Okay, the cost of that, well, it depends a lot on many things. Okay, it's difficult to give you a figure on that. Okay, we are in projects of hundreds of thousands of euros to millions of euros. Okay, depends mainly on the status of, for example, the 3D model that could be given to us, perfect. Okay, no cost for us. Also, the number of softwares and tools you want to integrate. Which are these softwares and tools and their brands? Okay, it's not the same integrating one enterprise asset management system with one brand than another in the terms of complexity, okay, because they are vendors that has a very close solution and it's difficult to integrate. There are others that think more openly and it's much easier. So it's difficult to say, but we are talking about hundreds of thousands to millions of euros or dollars. Yes, it depends on that. Also depends on the maintenance that you want to do. So it depends. It's difficult to give a figure, sorry. But the return on the investment. This is a key question, okay, that lots of clients ask us, okay. I always make a second question. How many are you spending now in maintenance? Do you know? For example, if you are on site and you need a drawing, you have to go to the office. Go outside the terminal, security process. Go to the office, find the right drawing. Coming back, it could expend, I don't know, 1 hour, 1 hour and a half, for just one single drawing. So how many hours do you spend in a year doing things with not added value? Are you able to answer? If you are able to answer, I would say the return on investment is all of that you can save, because you will be on site with your cell, access to your drawings, no need to go and come back. For example, this is a use case. Okay, so it is clear that you save money. It is clear. It's difficult to say a figure because our clients doesn't know how much are they spending on that. Because they have, I don't know, 10 people in their teams of maintenance, but they do not have KPIs related wasted time doing things with not added value. But it's clear that it has a return on investment, positive return on investment for sure, but it's difficult to give a figure. I don't know if I have answered properly. Sure.
And let me make you another question, because well, as you said, this is the first digital twin that has been implemented in a bridge, in a port. You have already been operating, or the port authority has been operating the digital twin for some time now.
Yes.
What is the feedback on the operation of that digital twin in these years, and what has been the learning for the oncoming projects that we need to develop?
Okay. Well, we started here working for the engineering team. Okay, they had a problem that they have to give service to the maintenance team, saying, for example, where the utilities were. Okay, we have discovered. Then the people of maintenance see the advantages of this digital twin, and they ask us to say, it's possible to incorporate here, for example, a tool that I can put a path here, say a mark, saying that I will cover all this space for maintenance and how it affects the operation? We said, yes, for sure. Okay, this will be very useful for us. Is it possible to have all the information, all the data of vendors, suppliers, drawings, technical specifications, all of that in the same digital twin? Is possible? Yes, for sure. Okay, let's put that. So then the operations at the maintenance team ask us to make more what you call use cases. And then when engineering team was using, maintenance team was using, then it came to operations. And they said, is it possible to integrate operations tools in the digital twin so I can simulate future scenarios or emulate future scenarios? We said, yes, for sure. So this is why in this particular project we have been working since 2018 with no stop until now. And now we are thinking on new use cases that came from the client. So at the first step, the client was very skeptic about the use and the return on the investment on that. And for me, the best proof that it is useful for them is that they are asking more to us. Okay? Yes? More things.
There's a question from the YouTube channel. Patsy is asking, well, first of all, saying thank you very much for the fantastic presentation. And he's asking, what are the next steps for the digital twin? Are you collecting live operational data with sensors for using AI for analysis and decision making?
Yes, this is the future or the next steps in which we are working right now is to connect IoT devices. Okay, here you have seen in this emulation, we are not connecting yet to IoT devices on real time, but we have connection with the SCADA, which is collecting data from IoT, okay, which is the same. Artificial intelligence applied to that, it will be on the simulation or the emulation side, okay? So, yes, we have done an evolution to the digital twin. We are incorporating all the new technologies, like artificial intelligence will be the next, okay, in the way that we are able to simulate future scenarios and to emulate future scenarios, okay? So, yes, I don't know if I have answered properly. More questions?
Well, hi, I'm Victor, one of the students from the Masters. So I have three, which I expect are quick questions. So first of all, I assume the operator is a public operator, is a public authority,
no,
or is it private?
It's a private operator.
All right.
It's called APM Terminals. It's a concessionaire that has a concession. Yes, it's a private.
Do you think that affects also on their willingness to invest on improving all of this?
It affects a lot, okay, because they are, in our case, it's much difficult to convince a private client to invest because they have to explain internally the return on the investment that we were talking, okay? Maybe with public entities they can do, let's say, exercises, okay, theoretical exercises, but with not asking for a return on investment as a private do, okay? In this particular case, it is a private, they are convinced and they are investing more. So which is, I think it's a key indicator for us. Okay.
So second one is, so you've shown lots of data connected to the model, so drawings, specs, etc. Where is all of that data stored? Is it in...
We have a data lake, okay? And each data is on their SQL. We are connecting SQLs, so there are different databases that they are connected. So the drawings are in the drawings, and we have configured properly the drawings, so we can connect. When we click, we know which is the drawing that has to be going there.
Okay. And then the last one, so we've mostly seen on the videos the 3D model,
yes.
But I believe that there's several softwares connected to it.
Yes.
So if you could give some more examples on the different softwares that are connected, like
we have connected the SCADA, which is Ignition, the Enterprise Asset Management System for the management. Okay, these are the two main tools that we have connected at this stage here. There are possibilities to connect. For example, we are talking with them to connect the TOS, the Terminal Operation System, okay, who decided how you move the cargo inside the terminal. It is possible also to be connected. But now, nowadays, we have these two main tools connected. Okay?
Great. Thank you very much.
Thank you. More questions? I'm sorry.
So another question from YouTube. Jeremy Blair is asking, how easy is it for you to maintain the digital twin, incorporating new tools, simulation, etc.? Do you develop everything from scratch or rely on already existing solutions for some part of the digital twin?
Okay. How the first part of the question was sorry, how you evolution the digital twin? Or how you manage?
Yeah, like how easy is it for you to maintain the digital twin?
To maintain and update, no? Well, it's easy depending on the information and the documentation that comes from our client, okay? We teach our client, once we finish the implementation of the digital twin, that they would be able to update if they have any change or they want to incorporate more data, they will be able to do that if they have the skills internally to do that. So here there are a lot of students from a digital twin master, okay, in which you will learn a lot of skills. Not too many people have these skills, okay? We prepare everything to be updated by the client, but if the client don't have the people, the right people with the skills to do that, they will have to hire an engineering firm like SENER or another engineering firm to update, for example, the 3D model. If you don't have a BIM specialist and you have a new gate, it's not possible by your own to update the 3D model. You will have to rely on an engineering firm to update that, or in a modeler. If you don't have the skills to integrate different softwares, you will have to go outside. So, but we teach how to do it, but some clients decided that I prefer to have this externally with a specialized company like SENER and not doing by our own. This was the first part. And the second part, sorry?
The second part was do you develop everything from scratch or rely on already existing solutions from some part of the digital twin?
Well, we develop, when we agree on what is developing a digital twin, okay, we are able to develop from scratch, as we have done. But we are able also to incorporate parts of the digital twin that came from our client. For example, now we are in attending in Australia, in which the 3D model will come directly from the contractor. So we have to receive this 3D model and integrate this 3D model, which we will not touch, with the other tools and softwares that we will integrate in the digital twin. So we will receive that. There are solutions in the market related to digital twin. For example, the platform. Okay, there are digital twins platforms where you allocate all the softwares, all the data. SENER, we have our own platform, but there are some clients that has his own platform, or they want to work with another platform. We are flexible on that. We will work on that, okay? There is no issue. If there are things that has been done, we will incorporate directly, yes. More things.
There's another question.
More questions.
From YouTube, from Vasi, and it says, how many self-developed programs were used to create such a useful digital twin? How much was already available on the market?
Can you repeat?
Yes. How many self-developed programs were used to create such a useful digital twin? And the second one is, how much was already available on the market?
Well, this digital twin is based on Autodesk solutions, okay? That was in 2018, which are different now, okay? This is something also that the vendors are evolutioning, okay? So we use to build that Autodesk softwares, let's say, or solutions. Why Autodesk? Because in SENER we have an enterprise agreement with Autodesk and we use Autodesk solutions, but we are flexible on that, okay? So also we did some internal developments and softwares to integrate the SCADA or the enterprise asset management, okay? This was done by SENER with the support of our specialists in the digital area of SENER, okay? This is the first. And the second question was, sorry?
And the second is, how much was already available in the market?
Well, all the, let's say, all related to the 3D model, or part of the 3D model was in the market, but we did some specific development jointly with Autodesk in this particular case, because it was not in the market, okay? And due to the agreement that we have with Autodesk, we were able to see, for example, with Forge, how we integrate with Forge with the different tools, okay? Something that we did specifically for that. That was not in the market. More questions?
There's another from YouTube.
What?
There's another one from YouTube.
YouTube is very active.
So, yeah. It's from Jimmy Valencia, and he says, will be there a technical article about this study case?
Yes, there is. Not will be, there is. Because when we submit our candidature for the award of the American States, in 2022 we published a briefing and there is a public information on that, yes. But I can try to send to you through the organization, yes. More things?
There's another question here.
More questions.
Patsy Cartel is asking, are the port authorities in Spain aligned with these types of digital twin developments?
This is difficult to answer. We have been explaining this to several port authorities in Spain, also to Puertos del Estado. Okay, they see that as fantastic, good things, but I think that they are a little bit far of that right now. It's something that we cannot change. Okay, we are trying to teach the advantages of all these tools, but right now in Puertos del Estado they did the BIM specifications in 2021, if I'm not wrong. Then they launched a pilot project for the BIM modeling, just BIM modeling, in a port in the Canary Island. But talking about digital twin, there are some port authorities like Barcelona that is talking about digital twin, okay? But they are not implementing this in this way. They are implementing more individual solutions that finally, if they connect everything, it will be a digital twin, but not right now with this view. There are some other locations in the world that I think that are more close to this approach of the digital twin than Spain. Unfortunately, this is what we have. More things. I think that we are run out of time. But
in relation to that, one of the good news is that in the course of Master of Digital Twins, we will be developing capstone projects. Students will be developing capstone projects, and there is a project of a conceptual design of a digital twin for the Port Authority of Huelva.
Okay, fine.
Who are really interested and willing to see the results of that and how it can contribute to.
Perfect. If you need our support, we will be happy to support any of the students on that. And I'm happy that Huelva is interested on that. Perfect. That's the way to improve.
Okay, so if there are not any other questions, I would like to thank Xavier for this fantastic conference. I think it has been really enlightening for everybody. But overall, I wanted to congratulate you for the project. It's a great project, disruptive project that you have developed. I guess that in a very difficult infrastructure environment and against and I think of 2018 developing this kind of project. I guess that there was a lot of reaction. I see for your presentation how you enjoy explaining it, but yes. I guess at the same time that you have suffered and sweat a lot in the development of this project. Yeah. Thank you also to Ivan for his presentation, for coming today, and particularly to SENER for their continuous support to the project, to the Escuela de Ingenieros de Caminos, and for always coming with us along this adventure that we are also having. I hope that it has been as interesting for everybody as it has been to me. Also, thank you to the attendees today to this room, and the attendees to the YouTube session. And in particular, it has been a great pleasure today hosting to 5 of the students of the master program. And hopefully we will have the chance to network a little bit at the cocktail that we have prepared. Sorry for those attending online that you will be missing that, but next time.
Next time.
Thank you very much.
Thank you to all of you. Thank you. Me encanta.